This video, we'll be learning how to solve forces problems that will be tested on the IB Physics SL exam. Before we start solving, it's important to remember these 2 tips to avoid making silly mistakes and to solve problems quicker. The 2 tips are to draw force diagrams after reading the problem and then create a given and wanted table after that. Now let's get into solving. Problem number 1. A girl exerts a 36 Newton horizontal force as she pulls a 52 Newton sled across a cement sidewalk at a constant speed. What is the coefficient of friction between the sidewalk and the metal sled runners? So our first step would be to draw our forces diagram. We can draw a rectangle to represent the sled and then start drawing our forces. So this is the rectangle. The first force acting on the sled would be the force due to gravity, which could be represented as Fg, and it's going downwards. The second force is the normal force, which points upwards. The third force is the force that the girl exerts, which can be represented as Fp. And we could draw that horizontally going to the right and say that's Fp. And finally, the last force is the frictional force, which can be represented as Fd. Now we could draw our given and wanted table. So the first thing we know is that the push force is 36 newtons. So we could say Fp equals 36 newtons. And we also know that the sled is 56 newtons in mass. So we could say Fg equals 52 newtons. And by reading the problem, we could see that the sled is moving at a constant speed, which means the acceleration is 0. So A equals 0 meters per second squared. And then what we want to find is the coefficient of friction, which we could represent as the symbol mu. Now I could write our forces equation and say F net equals Fp minus Fd. The reason why I didn't include Fn and Fg is because those forces are the same magnitude but go in opposite directions, so they just cancel each other out. So now we could expand this formula and say Ma equals Fp. Fp stays the same because it doesn't have a formula, and then minus mu Fn. And then since Fn equals Fg and Fg equals mg, then Fn equals mg. So we could say Ma equals Fp minus mu mg. And then now we could substitute our values. So we don't really know the mass in kilograms, so we could just keep that as m. Then we know A is 0, so times 0. And then Fp is 36 minus mu, which is what we're trying to find, times mg. And we don't know m, but we know what mg equals, which is 52. So times 52. And then if we just solve for that, mu equals 0.69. And that would be our answer. You help your mom move a 41 kg bookcase to a different place in the living room. If you push with a force of 65 newtons and the bookcase accelerates at 0.12 meters per second squared, what is the coefficient of kinetic friction between the bookcase and the carpet? So we could draw another rectangle for our bookcase. and then draw our forces. The forces in this problem will be the same as in the last problem. So Fg, Fn, Fp, and Fd. So now we could draw our given and wanted table, same like the last problem. So G and W. So we know that the mass is 41 kg. So we could say M equals 41 kg. And the push force is 65 newtons. And then the acceleration is 0.12 meters per second. So A equals 0.12 meters per second squared. And then we're finding the same thing. What's the coefficient of kinetic friction? So we're finding mu. Then our equation in this problem will be the exact same as in the last problem. So F net equals Fp minus Fd. Remember, Fg and Fn cancel each other out. So we could expand this formula. So Ma equals Fp minus mu Mg. M is 41. A is 0.12. Fp is 65. We don't know mu. And then Mg would be 41 times 9.8. And if we just solve for mu, we get that mu equals 0.15. Problem number 3. A 65 kilogram person stands in an elevator on top of a digital scale programmed to display weight in newtons. What does the scale read when A, the elevator is stationary, B, when the elevator accelerates upwards at 2 meters per second squared, C, the elevator moves upwards at a constant speed, and D, the elevator decelerates at 2 meters per second squared as it moves upwards. So for part A, we could just draw our elevator as a rectangle. And in this situation, we only have two forces acting on the elevator, which is Fn and Fg. And we can also just draw a person for fun. So Fg and Fn. So for part A of this problem, we know that the mass is 65 kilograms and the acceleration is 0 because it's stationary. And what we want to find is the normal force because that will represent the weight in newtons. So we could go ahead and write our table. And our mass is 65 kg. And we know A equals 0. And what we want to find is Fn. So our equation would be F net equals Fn minus Fg. So we could expand this formula. Ma equals Fn minus Mg. We could plug in what we know. M is 65 times 0, so that'll just cancel out. Equals Fn minus 65 times 9.8. Then just isolate Fn. And we get Fn equals 637 newtons. So for part B of this problem, it says that the elevator accelerates upwards at 2 meters per second squared, which means that the normal force would be greater than Fg because it's moving upwards. So we could represent that as drawing a longer arrow for Fn and then just drawing a shorter arrow for Fg. And then in our given and wanted table, the only thing that would change is the acceleration. So mass would still equal 65 kg, then acceleration would equal 2 meters per second squared, and we still want to find the normal force. And our equation would still be the same because Fn is the greater force. Now we could go ahead and write our forces equation. It would be F net equals Fn minus Fg. And then we could expand this formula. Ma equals Fn minus Mg. So 65 times 2 equals Fn minus 65 times 9.8. And Fn would equals 767 newtons. That's our answer for part B. For part C, the elevator is moving upwards at a constant speed, which means that A equals 0. So Fn and Fg would equal the same thing, just like in part A. So M would still be 65 kg, and A would be 0 because it's not accelerating. So, and we still want to find Fn. So our equation would be the same as in part A. So F net equals Fn minus Fg. And then we plug in the same numbers as in part A. So I'll just cut straight to the answer, which is 637 newtons. In part D, the person is accelerating. Cut that out. In part D, the person is decelerating at 2 meters per second squared as it moves upward. So even though it's decelerating, since the person is still moving upwards, A would not be negative, but the forces would change here. Since it's slowing down, that means that the force of gravity would have to be greater than the normal force. So we could draw something like that. And then the mass would still be 65 kgs. And then A would just be positive 2 meters per second squared. And we still want to find the normal force. Our equation would change now because Fg is greater than Fn. So we would put that on the left side. So Fg minus Fn. We can expand this formula and then plug in our numbers. So 65 times 2 equals 65 times 9.8 minus Fn. Then we get Fn equals 510 newtons.
Made it to this point in the video, then I know you really want to ace your next test. So be sure to like and subscribe to guarantee 100.